Good morning, everyone. Sorry I can't be there with you this morning. We're going to start off today by looking at some of the homework questions that you guys had from yesterday. So those are the practice questions that were on the back of yesterday's lesson. So if you want to pull out those sheets so you can check to make sure that you had the right answer, we'll go through those right now. I'm going to take up two of the different questions. So the first one I'm going to take up is number 1, where we have to state the amplitude and all the different key pieces of the graph, and then determine the equation of the graph. And they tell us right here that this is a sine graph, so we know that the equation is going to have a sine in it. So let's take a look here. So this is our graph here that we're given, and we have to pull out all the key information. The first piece is the amplitude. Remember, there's two different ways to determine the amplitude. The first way to determine the amplitude is by looking at our graph. Sometimes it's easy just to read it off the graph. For this one, we go from our axis of the curve all the way up to our maximum. Or, remember, we could go from the axis of the curve down to the minimum as well. And whatever that distance is, that would be our amplitude. The other way to do our amplitude is to use our formula where we do maximum minus minimum, and then we divide that value by 2 to figure out what the amplitude is. So in this case, our maximum here is 10, our minimum is negative 10, and then we divide that by 2. So in this case, that would be 10 plus 10, which would be 20. 20 divided by 2 is 10, so our amplitude is 10. And that's the same as we look from our axis up to here. That's a distance of 10 from 0 up to 10. So either way, you should have gotten that your amplitude was a value of 10. Similarly with the axis, we use the axis to help us with the amplitude. Our axis, remember, is that horizontal line that cuts our graph in half. And in this case, it's easy to see that it is at the y equals 0 on our graph, because above we have 10, below we have 10, so it cuts it directly in the middle. But remember, you can also use your formula for that one as well if you want to either double check or make sure you have the right one. Remember, the formula for axis is maximum plus minimum, and then we divide by 2 again. So we have 10 plus a negative 10 divided by 2, which 10 plus a negative 10 gives us 0. 0 divided by 2 is 0. So remember, our axis of our curve is 0. And remember, axis of the curve always has y equal to it because it is an equation. So don't forget to throw that y in front of it. So our axis is y is equal to 0. Our next one is the period. Remember, the period is where we do one full cycle, or how long it takes for one full cycle of our graph. So if we start here and work our way through our graph, we restart the cycle again here. So that means that our period is the length from 0 to 360. So our period is 360. And don't forget, these are measured in degrees. So it's 360 degrees. Then we look at our domain. Remember, these graphs of sine and cos, they always continue on in both directions forever. So even though there's not ones on these pictures, we know that there's actually arrows there that it continues on forever. So our domain then, there is no restrictions on x since it continues in both directions forever. So we know our domain is that x must be in the reals, since there are no restrictions. And our range, remember, the range is always dependent on the maximum and the minimum. So in this case here, we see that our maximum is up here at 10, and our minimum is down here. Oops. Our minimum is down here at negative 10. So our range is always dependent on our maximum and our minimum. And it's always that it's in between our maximum and our minimum. So from negative 10 less than or equal to y, then it has to be greater than negative 10, but less than positive 10. Otherwise, y is in the reals. And don't forget that should be less than or equal to. So throw your little equal to lines in there. So there is our range. Lastly is coming up with the equation. Now remember yesterday we looked at values in front of sine and cos that change. And remember that was the amplitude. The amplitude, which is right here, is now 10. So that means our equation, remember equations always have to have y equals, is that the a in front of the sine is 10. Other than that, nothing else has changed because everything else is the same. Because our amplitude has changed from 1 to 10, we have to throw that 10 in front of the sine x. And remember, amplitude affects our range. It changes the pieces of our range. Other than that, that is our final equation. Let's take a look at the second example. The second example I'm going to look at is where you had to graph the following functions, and I'm just going to do A here. Let's make this a little bit smaller. So A was graphing y equals 2 sine x. So remember this value that sits in front of sine x, it tells us that our amplitude tells us what our amplitude is. In this case, our amplitude is 2. And remember, that changes our maximum and our minimum. Our maximum then is a positive 2. Our minimum is a negative 2. And we know that our axis is that y has to equal 0 because that's one of the things that didn't change. We know that our period has to be 360 degrees because we know that that is something that also doesn't change when our amplitude is changed. We also know, and again, these are the basic things from our basic sine graph and cos graphs that we should have memorized. We know that our action points, they're every 90 degrees. And that, again, was something that doesn't change. That's from the basic graph. And we know that sine x, remember, it starts at the axis of the curve. So those are the key pieces that we need to help us do our graph. So looking at our graph here, we can start plotting our points. We know that it has to start at the axis here. We know that it has to have points every 90 degrees. And remember, those points every 90 degrees are based on our 3 key action points, which remember is the maximum, the minimum, and the axis. So we start at the axis of the curve, and we know that sine goes up, but we know that our maximum is now at 2, so we have to go all the way up to 2 at 90 degrees. And then we know it goes back down to our axis, which is at 180. And then it has to go down to our minimum. And remember, our minimum is negative 2 because our amplitude has changed. And then we go back up to our axis. And let's also do that to the other side. So again, we follow this pattern. If the pattern continues this way, that means it's going down to its minimum and back up to its axis, back up to its maximum, and then back down to the axis. Once you have your key action points plotted, then you can connect your graph. Try and do it as smoothly as possible. It should be a nice smooth curve. It's a little bit more difficult because I'm doing this on a computer. You should be able to draw a nice smooth curve. Don't forget your arrows at the end. And don't forget to also label your graph. Y equals 2 sine x. Hopefully, if you had any questions about the graphs, that answered them. If not, I can answer them for you when I'm back tomorrow. Today, what we're going to be doing is we're going to be doing the next section. So yesterday, you guys, we looked at the A value of our graphs, and that was dealing with the amplitude and the changes that it made to the maximum and the minimum. And today we're going to be looking at this K value that sits inside the square brackets. And this K value is what's called the multiplier. So A stood for amplitude, K, it's called the multiplier. And that's what we're going to be looking at and investigating how that changes our graphs today. So you guys should have this handout already. So you're just filling in the key pieces as we go. So example number 1 we'll do together. So just like yesterday, you guys should be able to graph your regular graph of sine x. And again, that should be coming second nature as to how to graph that. So let's first throw in our labels for our y-axis. We're going to go up by 1s here, 2, and then -1, and -2. And remember our regular sine x graph, it starts at the axis of the curve and hits its action points every 90. So at 90, goes up to the maximum. At 180, it's back at the axis. 270, it's down at its minimum. Then it's back up to the axis at, 360. There we go. And then again, we do that the same thing, but the other direction. So from here, it's going to go down to its minimum, back up to its axis, up to the maximum, and back down to the axis. So again, connect that together with your nice smooth curve. Don't forget your arrows and our label. So this is y is equal to our regular sine x. Okay. And then remember to do the second one, you just go into Desmos and type this equation into Desmos. You can use y if you want. Y equals sine 1/2 x. For the 1/2, remember you can type that in as a decimal. You can just do 0.5x. Once you've typed that into Desmos, remember if you click on the line, it'll show all the key action points. So once you've seen those, then make sure you plot them on this graph. So let's just do that together here. So you would have a point here. Your next point would be at 180 and 1. Then our next point is at 360 and 0. And then if we go in the negative directions, we have -180 and -1. And then back up to 360 and 0. And then again, connect your curve, or your points to make your curve. Throw your arrows on the end. And remember what you can do too to use Desmos is graph just the regular sine x graph in Desmos and then also graph your other graph at the same time so that you can compare the picture on Desmos with your picture to make sure that it does in fact match. Once we have it graphed here, we need to do our analysis of all of the key parts to see what has changed and what hasn't, just like yesterday, so that we can come up with the rules that we did at the end, the conclusion. So let's look at our analysis here. So again, we want to list out what's the same and what's different. So looking at this, we want to list out what's the same. So we look and see our maximum is still at 1 and our minimum is still at -1, so those hasn't changed. So max / min is equal to ±1. We also want to look at our amplitude. So if we go from our axis of our curve up to our maximum, we still have an amplitude of 1. Our axis of our curve is still the same. It's still y = 0. because our arrows continue on in both directions, our domain is still the same. So it's still x is in the reals. And because our maximum and our minimum are the same, that means our range is also still the same. So it's between -1 and 1. Otherwise, y is in the reals. Again, don't forget those equal signs in there. So those are all the things that are the same. Let's take a look at what changes we have. Remember, our changes come about because we were graphing y equals and comparing y equals sine of 1/2 x, which is 0.5x. So the changes that have occurred is you should notice the period is now different. Remember, our period for our regular sine x graph, one full set or one full cycle goes from 0 to 360. In this case, it takes from -360 all the way to +360 for our cycle to go through one full piece of our wave where it goes down and up. That's one full cycle. So that's a total all the way from -360 up to +360. That's a total of 720 degrees for our period. So that's something that has changed, that our period is now different. Something else that has changed as well, because our period has changed, is our action points. Remember, for our regular sine x, our black graph here, our action points were every 90. So every 90 it would hit an axis, a maximum, or a minimum. But now, because it's been stretched out and our period is a total of 720 degrees, notice that our action points, if we start here at 0, the next action point doesn't occur all the way to 180 before it hits a maximum. And then again, the next one before it hits the axis again is 360. So we notice that our action points are now every 180 degrees instead of every 90 degrees. Let's just put that description of instead of 360 and 180 instead of 90. And that's our analysis for our first graph here. Is that the only things that have changed by changing this k value in this first example is by changing our period and changing our action points. So once everyone has this down, what I want you to do is I want you to go through example 2 and 3, just like we did here and just like yesterday. Use Desmos to help you with your graphing and then do your analysis of what's the same and what has changed. So I want the video to be paused so that everyone can do that on their own first. Once you've done that, please go to the conclusions part here and see if you can fill in the conclusions yourself. So once everyone has had a chance to attempt questions or examples 2 and 3, the supply teacher will then play the video again to go through the solutions. And at that point, then you can check your answers to make sure everything's right. But again, try to see if you can come up with the conclusions yourself and come up with the formulas yourself based on the discoveries that you've made from looking at those examples. Because you'll have a better understanding if you're able to come up with them yourself than me just telling you what they are. So please pause the video at this point in time and have everyone attempt those questions. Once everyone has had a chance to attempt, then click play and finish off the video to check the answers. Okay, so at this point, everyone should have had a chance to go through examples number 2 and examples number 3 and try and give a chance at the conclusions to see if you can fill in the blanks here of what K affects and what the formulas for period and action points are. Let's just quickly go through the solutions to examples 2 and 3 to double check your answers. So first, for example number 2, your graph should have looked something like this, where black is your sine x graph, red is your y equals sine 2x graph. For things that are the same, the maximum and the minimum were still positive, negative 1. Our axis was still y equals 0. Our amplitude was still a value of 1. Our domain was still y, x is in the reals. And our range was still in between negative 1 and 1. Otherwise, y can be in the reals. The only changes with our graph being y equals sine 2x was that the period is now 180 degrees because one full cycle only took from 0 to 180 instead of 360. And our action points are now every 45 degrees instead of 90 degrees. So it hits at 0, then it hits a maximum at 45, it hits the axis again at 90, hits a minimum down here again at 135, and then again here at 180. So it's every 45 degrees that it's hitting those action points. So again, just double check to make sure that everything was correct in terms of your solutions. Let's take a look at example number 3. For example number 3, in this case, we were graphing cos 4x. So again, cos, remember for the general cos, it starts at the maximum at the y-intercept and then goes down to the axis, down to the minimum, back up to the axis, back up to the maximum for your general cos. When you graphed y equals cos 4x, it should look something like this green graph here. So again, all the things that were the same are the things that were the same in the first 2 examples. The only thing that changed in this case, oops, I forgot to change these numbers here, is that our period is now 90 degrees because it only takes to get from the maximum again to the maximum, it only takes 90 degrees instead of 360. And that means that our action points are every 22.5 degrees instead of every 90 degrees because that's half of our 45 degrees here. The first one starts with a maximum at 0. Then our next one is at 22.5, which is halfway to 45. Our next one's at 45. And that again continues on, so on and so on. So again, the only thing that's changed here is our period and our action points. Everything else has stayed exactly the same when we've changed that k value inside with the brackets with the x. So again, check to make sure that your graph is accurate and that your analysis is accurate. Let's take a look at the solutions, or the conclusions, sorry. So for our conclusions, I'm hoping that you were able to figure out that K affects just the period and the action points and nothing else. And for our formulas, I'm not sure if anyone was able to come up with these, but hopefully some of you were. For our formulas, period is equal to our degrees of 360, because that's our regular period, divided by whatever the K value was. So whatever the K value was inside of our equation, if you take the 360 and divide it by it, you would have gotten the period. So let's just see an example of that. So for example, when we had sine 2x, and that's the one that we were graphing, our period, if we do 360 and divide it by our K value, which in this case our K value is equal to 2 because that's the number in front of the x. If we divide 360 by 2, we get 180 degrees. which from example number 2, we had a period of 180 degrees. So that's the formula for period. So from now on, when I give you an equation that has a k value in it, you can figure out what the period is by taking the original period of 360, dividing it by whatever the k value is, and you'll get your new period of 180 degrees. Similarly, there's one of those for the action points. For action points, our regular action points, remember, are every 90 degrees. If we take that 90 degrees that our action points regularly are, and again, divide them by whatever our k value is, we'll get where our new action points are. So again, let's look at this example of example number 2 here, when we had the 2 as our k value. Our action points, if we use our formula, 90 divided by our k value, which in this case is 2, we get that our action point should be every 45 degrees, which again, you can go back to example number 2 and check. It was that our action points occurred every 45 degrees. Let's just quickly look at the next example, similarly with these equations. So when we do example number, let's do example number 1. When we do example number 1, that was when we were graphing sine of 0.5x. So in this case, that meant our k value is equal to a 0.5. So our period, which I'm just going to use p from now on, we take 360 and we divide it by whatever our k value is. In this case, it's 0.5. When we do 360 divided by 0.5, we get a value of 720. And again, you can double check with example number 1. Our period ended up being 720. Likewise, for our action points, which from now on I'm going to use the short form of AP, we start with it regularly at 90, divide it by our k value, which in this case is 0.5. And 90 divided by 0.5 gives us a value of 180, which again ended up being where action points hit. They ended up hitting at every 180 degrees in example number 1. So from now on, like I said, you can use these formulas, and these formulas are really important, and that we're going to be continually using them whenever we're graphing sine and cos to figure out what our period should be and what our action points should be. So with these conclusions, I want you guys to look at the practice questions that's on the back of your sheet. Give those questions a try. Anything that you don't get done in class, make sure that you attempt it for homework. And any questions that you have, come prepared with them at the start of class tomorrow, and I'll look at any of those at the beginning of tomorrow's class with you guys. So use your time wisely to get your practice questions attempted, and I'll see you guys tomorrow.